Good afternoon, everybody. Lecture number 5, almost done. We got one more after this. Today we focus on functional groups. We need to understand and identify a functional group in an organic molecule and basically how to name and draw them. So, a functional group basically means there's something in there other than carbon and hydrogen, which is what we've dealt with all to this point. Everything we've dealt with is carbon and hydrogen. Well, what happens if I start putting oxygens in there and nitrogens in there? Again, non-metallic elements. What if I put a chlorine in there or a bromine in there? What do I do and how do I name that stuff? So this is what we're going to deal with today with functional groups. It might be a little bit long of a video. Notice there's 11 slides, which means there's probably 10 and then not even so many, but there's 7 different kind of functional groups. So we got to get through every one of them in this video, so it might take a little bit, okay? Um, Hydrocarbons and those isomers are basic because they're just carbon and hydrogen. Basically now, what happens when I add oxygen, nitrogen, and all sorts of other things in? And so then we get to this, what we call functional groups. We have more than just a hydrocarbon when I have a functional group. I also have a complete table. In the reference tables, they're going to describe for me what each of these are. Okay, a halide gives me a fluorine, a chlorine, or a bromine, or an iodine, and it tells me how to name them. Fluoro, chloro, bromo. Alcohol ends in an OH, which is not a base, because a base would be a metal with an OH, like NaOH. Here I'm going to have a chain of carbons with an OH, so that is going to be different. Okay, and just so we're clear, this R here just means rest of molecule, which is any number of carbons. It could be a methyl, it could be an ethyl, it could be a butyl. We're not going to, it's generic. That R is a generic for some number of carbons. An ether has an O in there with the carbons, so there's a carbon on either side of an O. An aldehyde has a double bonded O to a carbon and an H, and notice it has to be a terminal carbon. It is on the end. Okay. A ketone is an oxygen double bonded to a carbon somewhere within the chain. An organic acid, this is the COO. This is a double bonded oxygen to the terminal carbon, then also an OH. Remember, the COO ends in OH, and it was the exception to the acid rule. And here it comes again. Esters, double bonded O with an O inserted into the chain, so then there's some sort of carbons at the other side. This 2 O's, ester. An amine has got a nitrogen in there somewhere instead of a carbon, and then an amide specifically has a double bonded O with a terminal hydrogen. Okay, we're going to go through each of these and give you all the rules and how to name them, and then we'll be done with this video, and unfortunately it might take longer than you'd like. But again, I'm giving you 3 weeks for this unit because this stuff is pretty, I'm not going to say it's easy, because after a while though it should get easy, but there's a lot to it. So we're just going to take our time. I'm going to make the video, you're going to watch it, and you're going to be able to do it with some practice. Halides is a halocarbon. There is specifically a fluorine, a chlorine, a bromine, or an iodine in there somewhere. Okay, same rules as naming the hydrocarbons, except for now you have to state the location of the halogen along the carbon chain, lowest number possible. So here's 2-chloropropane. Everything's the same. I'm going to always start with the prop. I'm going to start with the suffix. The prefix on there, right? So prop is specifically 3 carbons. 1. I drew a 3. Mr. Milks, you made too many videos in one day, I'll tell you what. All right, 3 carbons. 3, carbon, carbon, carbon. Ane tells me that they're all single bonded, so all the same things as before. But on the second carbon now, I'm going to have a chlorine. 2-chloro, Cl. Fill in my hydrogens so that all the carbons have 4 bonds. And we're good. Let's go backwards here. Here I have 1, 2, 3 carbons in a row. So 3 carbons is a prop. And it's an ane. And you know what? I'm going to erase that and write it over a little farther. Give me some room for the prefixes. Sorry about that. And write propane over here. Because then I have this methyl on the second carbon, and I have a fluoro on the second carbon. So I'm going to call it 2-fluoro, 2-methyl propane. I'm going to do the fluoro first because fluoro is more complicated than a methyl because it's just a carbon. Fluoro is more distinguishable. Okay, let me do this one. I see a 2,2,3 trichlorobutane. Let me start with the bute. Bute is 4 carbons. 1, 2, 3, 4. Ane tells me they're single bonded. I have 3 chlorines, 1 at the 2, 1 at the 2, 1 at the 3. So there's a chlorine, and a chlorine. Fill in the rest with hydrogens so that carbon has 4 bonds. Every carbon has 4 bonds. And there we go. So it's the same thing as naming the anes, except for I have to have the name of the halide, and the name of the halide ends in O. And I'm going to put that first. Okay. Alcohols. One or more of the H's is replaced with this hydroxyl OH group. They're going to end in -ol. Ethanol, methanol, propanol. Okay. I must also state the location of the OH so I can draw it and write it. And remember, alcohols are covalently bonded. They're not the bases, right? There's no metal in there. So, propanol, see table R, because it's written there for you. I'm going to let you do that. Let me do, here's my OH. I don't like the way it's typed. I a lot of times will write it like this, branch with an OH. You'll see me do that. But this is an alcohol. I have 1, 2, 3, 4 carbons. 4 carbons is a bute. All carbons are single bonded, so it's an ane. I'm going to count this way so that this is the lowest number carbon. And so now it's 2-butane, and the butane becomes all. 2-butanol. Okay, that's how we do alcohols. On primary alcohol. Primary alcohol is that it's attached to the first carbon. Okay, 1-pentanol. A secondary alcohol, the OH, is attached to the carbon that is attached to 2 other carbons, or in the middle, right? So here, I got a carbon, 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 carbon. I really don't like the shorthand. And there's the second carbon, and I have 1, 2, 3, 4, 5, 6. 6 is where I get my hex. OH, I get my all. My OH is on the second carbon. Okay. Tertiary alcohols is attached to a carbon which is attached to 3 other carbons. Okay. So this particular alcohol down here is attached to a carbon that has basically, it's in the chain with a methyl. So it's attached to 1, 2, 3 other carbons. That's a tertiary. And we call that 2-methyl 2-propanol because in carbon 1, 2, I have a methyl and an alcohol. Okay. Dihydroxy alcohols just means there's more than one OH group. So I'm going to try and draw this one out, and then I'll click on the button and see if I did it right. I have ethane. F is 2 carbons. And it says I have a diol, which is 2. I have 1 on the first carbon and 1 on the second. So there's an OH here, and there's an OH here. I need 4 bonds on each one. So it should look something like that. Let's see if I got it right, Mr. Milks. Beautiful. This one just has them right on the end. It really doesn't matter if they're here or here. Okay. I'm going to let you draw this one as a U-do, see if you can get it. Notice, do it the same way. I have a prop is how many carbons. Ane is single bonded. 3 alcohols, 1 on the 1, 2, and 3. This is a U-do. We'll see how you do. All right, 3, ethers. Ethers, I see an O bridging between 2 carbons in my hydrocarbon. So I name the two branches off the O, alphabetical if necessary, and then add ether. So let me show you what that means. So here it says I name the two branches on either side. So two carbons is an F, and I have a diethyl. So there's two ethyls. This is diethyl ether. Okay. I'm going to leave this one for you because it's actually in your reference tables, I believe. And this is a U-do. And this one's a me-do. Butyl propyl ether. Ether means I have an oxygen in the middle. On one side, I'm going to have a butyl. And I look in the reference tables, but is 4 carbons. Doesn't matter which side I write these on. There's 4 carbons. On the other side, I have a prop, and a prop is 3. 1, 2, 3. Fill in my H's. I'm going to leave them as dashes on this time for lines. That's going to be the shorthand you learn anyways. Butyl propyl ether. Each dash has a hydrogen in it. I just didn't write them. Moving right along, Mr. Milks. Thank you for going faster. Aldehydes. Aldehydes. There's a famous one, isn't there? There's a certain aldehyde that gives you that new car. Formaldehyde. Yeah, formaldehyde. That's what we use to embalm people. Gives you that new car smell, that carpety, new carpet smell is a formaldehyde. Wonderful. There is what's called a carbonyl group, which is a C with a double bonded O. That's it's on the end, terminal. We just you take the E off of the ane and give it an al. And remember, this is in the reference tables. You'll see that all the names end in al, and it gives you a very, very specific way. Now notice it does say very similar to ketones, so beware. Okay, they are going to look very similar to ketone, except for a ketone. This is not at the term. This double bonded O is at a middle carbon, not a terminal carbon. Okay, propanol is in your reference tables, so that's a U-do. I'll talk you through this one. 1, 2, 3, 4, 5 carbons. 5 carbons is a pent. It's a pentane, so that'd be ANE, right? Because it's all single bonded. I'm going to take off the E and add an AL. Pentanal. Pentanal, and I could say it's a 1-pentanal, but when I don't have the 1, I assume it's on the first carbon. So 1-pentanal or just pentanal, either will do. As a matter of fact, let me go back. Mr. Milks, correct yourself. It's actually customary to not write the 1 because it has to be on the terminal or it's not a aldehyde, okay? And if it's on the other side, whoa, Mr. Milks, what'd you just do? If this circle is on the other side, let's pretend I moved that whole double bonded O, it would still just be 1-pentanal. So pentanal, I really don't need to write a 1, it has to be terminal, okay? Ketones, I have the same carboxyl group, C with a double bonded O, but now it has to be on the interior of the carbon. I changed the name, it ends in -one, and of course I need to give me the number of which carbon it's on. So 2-pentanone is in your reference tables, so that is a U-do. One for an example, Mr. Milks does, 1, 2, 3. 3 carbons is a prop. Single bonded, so it should be an ane. And it's a ketone, so now it's propanone. Lose the E and put an one. That's simple. Organic acids, moving right along. This is what I call the COO. The COO is called a carboxyl group. There's going to be a C double bonded to an O, single bonded to an OH to give me the COOH to end with, okay? I take off the E, put an oic acid at the end, and then I have it. I generate H plus ions in solution. It is an electrolyte. It's a real quick, review of acids and bases. I see propanoic acid, so that's a U-do because it's in table R. Mr. Milks will do this one. I have 1 carbon. 1 carbon is a meth. one carbon has got to be a single bond, so it's an ane. I take off the E and put in oic acid, following my naming rules. This ane, let's say that this wasn't meth. Let's say it was something higher like hex. Hex is 6 carbon. Hexane oic is different than hexene oic. Notice this would have the double bond. The ane and the ene are still very important, so we need to pay very careful attention. These things are very, very specific, and so we can go forwards and backwards. It needs to be. Esters, the trickiest of all, the functional group. I name the first word in the name according to the branch coming off the O inside the chain. Last word in the name corresponds to the number of carbons on the other side of the O, including the C in the functional group itself. E ending gets replaced with O8, known by their strong, fragrant aromas. In organic lab in college, I believe it's organic too, you get to make some of these things. Some of them smell very terrible. Some of them smell very wonderful. Okay. Let's see. Neither of these are in the reference tables, so I'm going to leave you with ethyl. I will do the other two. So what we need to get straight is this little piece about this. Okay, so it says you name the first word in the name according to the branch coming off of the O side. So that's this. So here's the O. This is a methyl. So this is going to be methyl. And then I get the 3-carbon chain. 3-carbon chain is prop. And it's propane for 3. So it's propan O8. Methyl propanoate. Okay. Here I have a propyl methanoate. So propyl is going to be on the side of the oxygen. Let me start by drawing the C double bonded O to the O, because that's where I know I have to put the propyl. Okay. Now propyl, specifically on the other side of the O, has 3 carbons. 1, 2, 3. Let me go ahead and fill in my H's. I'm using the dashes for now for H's. And then on the side of the carbon that doesn't have the O, I have a methyl, which is 1 carbon. So notice this one has nothing to do with the number of carbons. I actually have more carbons on the right-hand side here. This particular one has to do about with where that specific O is, and that's how I have to use those rules. Okay? Amines have nitrogen in them. Amines, N alone with only H's seen within the carbon chain somewhere. Okay? I changed the E ending of the hydrocarbon to amine. The amine group number location should be noted as to where it falls in the chain. If you see a double bonded oxygens coming off the chain near your nitrogen, it's not an amine. That's the next one, and we're going to get to that one. Okay? So let's see. 1 propanamine to pent. I'm going to leave the 1 prop as you do, and I'll do the next 2. So 2 pentanamine. All right, so pent, 5 carbons. Check to make sure I draw right. So it's 5 carbons. On the second carbon, I'm going to stick in an N. Okay? And now it's hydrogens. So it should look like that. Okay? It should look like that. Wait. did I have to do it this way? My instincts have changed. Sometimes I overthink things. The N is the second molecule. That's how we do that. So here, this is 2 right away. 2, 1, 2, 3 carbons. 3 carbons is a prop. Single bonded just like here, so it's AN, so it would be propane. Lose the E, and it's amine. Spell better, Mr. Milks. 2-propamine. Okay, sorry about the mistake on the one. Last one. I know it's taking forever. It's taking forever, but there's 9 of these things, so I thought there was even 7. I don't even know more than that. Amides. Here we go. You'll not only see an N in the carbon chain, but you'll also see a C double bonded to an O attached to the nitrogen. Okay, so this one's tough. Here's a U do, because it's in table R. I do butanamide. Okay, here we go. So it's going to end in amide. Okay, bute is 4 carbons. The nice thing about these is that they are always terminal. So it's 4 carbons. On the last carbon, I'm going to have a double bonded O followed by an N H. And I lied, it's not always terminal. And I wrote an H instead of an N, so I'm doing too much at once, Mr. Milks. And this is going to have H's on it. 4 bonds on that carbon, 4 on that, 4 on that, 4 on that. Done. So butanamide, bonus. And we have functional groups with branched hydrocarbons. Great. Ethyl propamide. Okay. So here is where the ethyl is on the other side of the prop. So start with the prop. Prop is 3 carbons. 1, 2, 3. And there's my double bonded O and my nitrogen. And then I have to have an ethyl on that hydrogen or nitrogen, and an ethyl is 2 carbons. So there we go, like that. Fill it all in. 1, 2, 3, 4. 1, 2, 3, 4. This carbon has 4. Nitrogen makes 3 bonds, not 4. Here's 4. Here's 4. Remember, each one of those dashes has an H in it. That is the shortcut I will accept as we move forward. Functional groups with branched hydrocarbons. So basically, there's a pentanal, and on the second carbon, I'm going to put a methyl. So let's start with how we talk our way through this. Pent is, of course, 5 carbons. 1, 2, 3, 4, 5. Go to reference table R. I'm going to look on the right-hand side and see which one ends in ANAL. ANAL is an aldehyde. An aldehyde says there is a terminal H with a double bonded O. Okay, and then the 2 methyl. So this is my first carbon. On this carbon, there's a methyl. Bam, done. Okay, this particular one has an alcohol. I see the OH. I see 1, 2, 3. So 3 carbons is a prop. They are single bonded, so it's propane. I have an alcohol, so it's propanol. OL, not AL. The alcohol is on the second carbon. Also on the second carbon, I have a methyl. So 2 methyl, 2 propanol. Done. Don't forget about the U-dos. I'm not going to forget about the U-dos. You don't get full credit without them. Sorry that this thing was so long, but now all 9 that we covered in this video, all 9 functional groups, which show me where I can find something other than a carbon or a hydrogen. So we have lots of practice packet to work on these. Still no quiz yet, so you got lucky there. And Mr. Milks is signing out for the day. Oh my gosh, 25 minutes, Mr. Milks. Shoot me in the head, you just said. Woo! No, I didn't really mean to shoot you, of course. I mean, 25 minutes is way too long. Sorry about that. This is a long, long piece. Be well. See you guys in class.